So the graphs of logarithmic functions are going to have a few key pieces of information. First of all, the point 1, 0 will be on every logarithmic function, unless we move it, stretch it, something like that. But this is on every parent function. How do you remember that? Because if you print logarithm, the first two are your initial point, okay? Or are your starting point, sorry. That's where it hits the x-axis. So, what else do I know? I know that the point base comma 1 is also on the graph. So if your base is 10, then the point 10, 1 is going to be on your graph, okay? If your base is a half, then it's half 1, okay? So your whatever your base is, comma 1 will be on the graph. So if I have an increasing, then it's going to come up this way and hit and go that direction. So you'll notice that if this is your increasing logarithmic, okay, there is a vertical asymptote at x equals 0. So you've got a vertical asymptote that slices through the x-axis at 0, okay? And then your key points are 1, 0, and then base, comma, 1, whatever that is, okay? So if you have a decreasing function, or your base is between 0 and 1, if your base is a improper fraction, it's going to be decreasing. So it's going to be coming down, and it's going to look like this. Okay, so it'll be decreasing as you read it from left to right, but you still have your vertical asymptote at x equals 0. Okay, so in this case, you've got a point at 1, 0, and then you would have another point at half 1, okay, and then a fourth, and then, you know, whatever, going from there. So you'll be positive between 0 and 1, and you'll be negative after. So those are the key points. So what we want to do now is look at these equations, and we want to find what the graph looks like. So we're going to draw a quick sketch. My base is 3. So we know if my base is 3 that the point 3, or base, comma 1, is going to be on the graph. We also know that the point 1, comma 0 will be on the parent function. So I know that, but here's what I also know, and we know this. So here's a hint. This is going to shift it. So I'm going to show you why it shifts it in just a second, but it's going to shift it to the left 4 units. So if I draw my rough sketch, it should be going through 1, 0 and 3, 1. So this should be the graph of my function with a vertical asymptote at x equals 0. Well, here's the deal. If you'll notice, your domain starts at 0 and goes to positive infinity. Okay? My domain starts at 0 and goes to positive infinity. So here's how I'm going to note that. Okay? Normally, my domain will be between 0 and positive infinity. Notice it's not equal to 0. I've got a vertical asymptote at 0. That's if I haven't done anything. So let's take our argument. Our argument is actually x plus 4. So I have 0 is less than x plus 4 is less than infinity. And now I just need to solve for x. So I need to subtract 4 from all 3 places. So I'm going to subtract 4 here, subtract 4 here, and subtract 4 here. So I get a negative 4 is less than x is less than, well, what's infinity minus 4? It's still infinity. Okay, you can't just take 4 off of infinity. So what I have now is my domain is going to go from negative 4 to positive infinity. So I find out that I shift this thing, instead of it being here, I'm going to pick this thing up and shift it left 4 units. So he'll look more like this. So you pick up your asymptote and you go with it. So originally my asymptote was at 0. Where's my asymptote now? My asymptote will be at x equals negative 4. Okay, so let's do it again. We have an increasing logarithmic function. He's increasing because it's bigger than 1. He's increasing because he's bigger than 1. And I want to draw a rough sketch of the parent function. So my rough sketch is going to be, I've got a point at 1, 0, and I've got a point at base, comma, 1. So 4, comma, 1. So that looks like this. I've got one here and then 4, 1. So I've got an increasing logarithmic function. So as you read it from left to right, he'll be going up. You've got a vertical asymptote at x equals 0. Well, that would be your parent function. But what are we doing? My domain has been affected. So we're going to figure out that this moves to the right 7 units. So how do I do that? My domain would normally start at 0, not touch it, and keep going to positive infinity. So I have, normally, it's from 0 to positive infinity. But what do we have instead of x? We have an x minus 7. So I'm going to go from 0, x minus 7 to positive infinity. And now how do I get x by itself? I add 7 to all, add 7, add 7. So I end up with 7 is less than x, is less than, what's infinity plus 7? It's still infinity. Okay, that's like taking all of the sand in the ocean and plopping 7 more grains of sand in there. You're not going to know a difference. So this new domain becomes 7 to positive infinity. Notice that you cannot touch the 7. You're going to get infinitely close to, in this case, 0, but never touch. And then where's your asymptote going to go? Well, just like my asymptote was at 0 here, and then it moved to -4. Along with the graph. This time my asymptote is going to move to over here. So I've got a vertical asymptote at x equals 7. Okay, so what would that look like? You're going to pick this thing up and you're going to plop it over 7 units like this, and then you're going to have a vertical asymptote right smack next to it. Okay, so this would be at 8 and your asymptote would cut through at 7. So let's look at the last one because it's a little bit differenter. Okay, what is your differenter? What is your base? Your base is E, okay? My dog was banging on the door. Anyway, what is our base here? Our base is E. So remember that E is approximately 2.718283, blah, 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 so on and so forth. So this is an increasing function, okay? So my key points are going to be at 1, 0 and at E, comma 1. So what does that look like? What I have is this little picture that looks like this. I should have a vertical asymptote at x equals 0. And then I've got a point at 1, 0 and at E, comma 1, which is roughly, it's between 2 and 3. Okay, so he's going to look like this. So that is the graph of my increasing logarithmic function. Well, we have something different. So what is our domain usually? Our domain is usually between 0 and infinity. But what do we have? We have a 3 minus x. So our 0 is less than 3 minus x is less than infinity. So I need to get x by itself. I'm going to subtract 3. So I've got a -3 is less than -x is less than, what's infinity minus 3? It's still infinity. Okay? But this is -x. So I need to divide everything by -1. Now be careful. What happens when you divide by a negative? You flip your inequalities. Okay? So this is going to become a +3 is greater than x is greater than -infinity. So if I read that, that means that 3 is the biggest, -infinity is the smallest. So my domain is going to go from -infinity to 3. Okay, so I flip it. So what this looks like is actually, he's going to come this way because I flipped him. Okay, and pardon my drawing, it's not really the best. But this thing will be shooting off that direction. And then where is my vertical asymptote? My vertical asymptote will be at x equals 3. Okay, so your domain is from -infinity to 3, so it's the red thing. And then as soon as I approach 3, I'm going to have a vertical asymptote there. So finally, what are we going to do about these graphs. So looking, I've got 3 graphs to choose from, so I want to look at my bases first. This base is 2. That tells me that he is an increasing logarithmic function. This base is a third. That tells me he's decreasing because he's between 0 and 1. This is 3/4, so that tells me he's decreasing because he's between 0 and 1. So there's only one increasing function, and that's going to be your red one, that's A. So if you ignore this stuff, you'll see A is increasing. Okay. He also, if you look very carefully, will travel through the point 1, 0 and 2, 1. So the scale is off just a little bit, but there you go. Okay. So the next thing I want to look at is I've got to choose between these two. So if you will remember when we were talking about exponential graphs, we said that the closer they got to 0, the flatter they got. Okay. So with exponential graphs, you can't see what I'm writing. Okay. The closer my base is to 1, the flatter, I put fatter, the flatter, okay, my function would be. The flatter it would be. So if I get further away from 1, it's going to be steeper, okay. The inverse of an exponential is a logarithmic. That's why for our inverse, we had y equals 0. And now for our inverse, we've got x equals 0 for our asymptote. Okay. So when I look at this, for logarithmic graph, the opposite is going to be true. So for logarithmic graphs, the closer my base is to 1, the steeper it's going to be. Okay. So the closer my base is to 1, the steeper it will be. So looking at these two, I would like to know which one is steeper. Is C steeper or is B steeper? Okay, so I can look at this one of 2 ways. I know that the point 1, 0 is on every logarithmic function and the point base, 1. Okay, so if you look at that, my base on this one is a third. So if I look at that, this is about a third of the way over. That blue one is about a third of the way. I know the scale is a little bit wonky. Okay, the green one would have base, 1, which would be 3/4, 1. So that's why it's going to be steeper. Okay, this green one is a whole lot steeper than the blue one. So the green one is going to be a base closer to 0. I'm sorry, good grief, a base closer to 1. The green one is going to be a base closer to 1. Okay, the blue one will be further away from 1 than this one is. So this is your green function, which is C. And this is, I just said it backwards. This is your green function, which is C. And this is your blue function, which is a third. So look at how steep he is here. Okay, and that tells you because the point, base, 1, is on the graph. Okay, so that is it for 5.2.